In section 5.4, we're going to work specifically on equilateral and isosceles triangles. Remembering that equilateral, everything is equal, all the sides are equal and all the angles are equal. And in isosceles, there are two that are the same. So we're going to review that here. So one thing that it reminds you of is that in isosceles triangles, we have got at least two of the sides that are congruent, and which means then that two of the angles are congruent. And here's how it's labeled. So in vocabulary, they're going to talk about base angles. The base angles are formed from these two legs here. This angle over here is called the vertex angle. So that would be sort of like the side angle side thing that we just kind of talked about. It's an included angle. We're not talking about that guy when we're talking about isosceles. We're talking about the two legs that are congruent, which means then that these two base angles would be also congruent. The first theorem that we're going to talk about really dives into this base angle a little bit more. So it's saying that if two sides of a triangle are congruent, then the opposite angles are congruent as well. So, for instance, this side is congruent to this side, so that means the angle opposite of this guy and the angle opposite of this guy. These two guys then are going to be labeled congruent. And that, of course, is an isosceles triangle. I have two congruent sides, and their opposite or base angles are also congruent. So this theorem says that if we have two sides that are congruent, then we know that these two angles are congruent. In theorem 5.7, it's the converse of the base angle theorem. So remember, converse, it just flips it around. So this time it says that if I have two angles that are congruent, those base angles are congruent, then I can conclude that these two sides would also be congruent. So it's just opposite. Before it says if these sides are the same, then the angles are the same. The converse says if the angles are the same, then the sides are going to be the same. Now the last two parts today are going to talk about equilateral triangles. And in this one, it's a corollary, so it's kind of like an offshoot of what we were just talking about. And it's saying if it's equilateral, meaning all the sides are the same, then I can also conclude that it's equiangular. Sorry, I can't talk today. So we got right. This one is saying that if all the sides are the same, then all of these angles are going to be the same, which is going to be important when we solve today, because remember, in an equilateral triangle, all of those degree measures have to be 60 because triangles are worth 180. And 180 divided by 3 is 60. Our last one today is then the converse of what we just said. So this time, if we say we have all equal angles, so all of these angles are equal, now I can conclude that the sides are also going to be the same.